Now, before we move on, we also need to talk about some of the other important characteristics that we need to know about quadratics. So again, this is our standard form. And if it's going to be a quadratic equation, that means a can't be 0. Because if it's 0, this term is no longer there, and then it's going to be a linear equation. Okay? So a can't be 0 in this form. All right, again, our shape is going to be a U shape, and it can either open up or it can open down. And that point is going to be the vertex, so at the very bottom or top of our U shape. So I'm going to draw just a little bit bigger U to kind of talk about the rest of this information. So if we're thinking about it on a graph, so here's just kind of a general XY graph, and let's say that we have a quadratic that looks like this. So we have a y-intercept. So when I'm looking at that, the y-intercept is where it's crossing the y-axis. So in this example, here's our y-intercept. So to find it, remember that we know our x value is 0. And we're trying to find our y value. So we're just going to substitute 0 in for all of the x's and then simplify. So again, when we do that, essentially, when it's in standard form, if we're substituting 0 in for the x's, the first two terms are going to cancel, and we're left with c. So a short way of doing it, when it's in this form, so it has to be in this form, is that our y-intercept is always just going to be whatever c is. Right, the next thing is the axis of symmetry. So this is a line that cuts our graph in half. So remember, at the very bottom of our U shape, this is our vertex at HK. The axis of symmetry is going to go right down the middle, so through the vertex. Okay, so this is I'm going to abbreviate it as AOS for axis of symmetry. So since it's a vertical line, it's always going to be in the form of x equals. And then since it's going through H is our x-coordinate, it's going to be equal to that. So the axis of symmetry is always x equals whatever H is. Okay. Now again, it's also important to note that our U shape is always symmetrical. So if I kind of draw a horizontal line here, these 2 points have to be the same distance away from wherever that axis of symmetry is. Okay, and again, we've already talked about the x-coordinate of the vertex. So we're going to use h equals negative b over 2 times a to find our x value of the vertex. And then our y value, we take whatever we get for this number and we substitute it in for the x's to find y. So I'm going to write it as f of h. And then our direction that our graph opens, so it's either going to open up or down. So up or down. And that is still dependent on our a. So if it opens up, that means a is positive, our a value. And if it opens down, then a has to be negative. Okay? So I'm talking about this number in front. So if this is a positive number, our graph is always going to open up. If it's a negative number, then our graph is always going to open down. And then our domain, because of our shape, the domain for these is going to be all reals, no matter what. And then our range is going to depend on A. So if our A is positive and it's opening up, then we're going to have y greater than or equal to, and then whatever the k value is, because that would be the smallest y value on your graph. So if it's opening down, so if it's making this shape where it opens down, so that point is sitting at the top, so that means that we need everything below that point. So it's going to be less than or equal to k for our range. And then how to make our table to graph. So again, when we are making our table, so we would make our XYT chart. We put our vertex in the middle, so that's our H and K. And then we're just picking points on either side of our H. Okay, so we pick the X, and then we substitute in to find Y. And then whatever those numbers are, we're graphing those, and then making our U shape to connect them all.